Kia ora Year 11 and Year 10s. I'm making this video to go through some of the revision material you've got on sequences and series. So this video is going to look at the worksheet from Mr. Hawke that was written by Mr. Hurring, which is excellence questions on arithmetic sequences. The questions in this worksheet are all quite similar, but remember that when you're looking at a problem when you don't know that the heading of the worksheet is arithmetic sequences, you have to be able to very easily and confidently spot whether it's an arithmetic sequence, a geometric sequence, or something else where those two things aren't going to work. So the two formulae that we're going to use for arithmetic sequences are these. The first one gives us the value of a particular term in an arithmetic sequence, and this next one, which I'm going to use about 8 times in this video, gives us the total when we add the terms up. So really quickly, an arithmetic sequence is one where there's a constant difference between the terms. So I'm just doing this one that's over here in the example. Here we've got the terms are going up by 3 each time. So D is 3, and the first one we call A. And you've probably proved in class where those two formulae come from, but here we're just going to use them. Now what we're going to find in every question in here is that when we need to figure out how long it takes to reach a particular total, we're going to be solving a quadratic equation. And in this video, I have done it using the quadratic formula. Up here, it talks about using your graphics calculator. Near the end, where I got really sick of doing the quadratic formula, I did switch over to doing it that way. And that's fine for the NCEA Level 2 assessment. If you're doing the Cambridge exams with sequences and series questions, though, you really do need to show all of your working, and you're not allowed to have a graphics calculator in that exam. So please make sure you are very fluent with quadratic formula questions, especially watching out for negative coefficients. All right, first question. Henry goes for an 8.5 kilometre run on the first Sunday, and he increases that distance by 1.2 kilometres every week. After a number of weeks, he's run this far, right? How many weeks has he been running for when his total is this? And then calculate when he'll surpass 1,000 kilometres in total. So what we have to do is turn that into one of these formulae, and obviously the one we're going to use is this one here. So the sum of n terms, and we're going to solve it for n. So pause the video, have a go, and then you can follow through my working. Or, of course, you can just stop watching the video, but then you won't find out the answer. So we've got 253.5 is equal to n over 2 times 2 times 8.5 plus n minus 1 times 1.2. And we've got that because A is 8.5 and D is equal to 1.2. Rearranging, we get 507 is equal to n times 17 plus 1.2n minus 1.2, and expanding this gives me 15.8n plus 1.2n squared. So, setting the quadratic equal to 0 will give me 1.2n squared plus 15.8n minus 507. Now I'm going to do the quadratic formula on that, and that's going to give me that n is equal to this. So 15.8 squared minus 4 times 1.2 times negative 507 divided by 2.4. Right, that works out to give me these two values. It gives me n equals 15, or n is equal to negative 28.2. But we know that n must be greater than 0. So 15 weeks is the only solution, or the only realistic or sensible solution. And then we're just going to put our answer into context and say that he has been running for that many weeks. In this case, we came up with an exact value here, which made it pretty easy. In the next questions, we're going to have to carefully look at what happens when we're halfway between one week and the next week. In the next question, we're asked calculate on which week he will surpass 1,000 kilometres in total. So I'm going to do the same thing here. I'm going to pause the video to do the quadratic formula working, but I'm solving this. when I work this through, so I'm going to skip through to the quadratic just to speed the video up. We're going to get to this 1.2 n squared plus 15.8 n again minus 2000. If you're not sure about where those intermediate steps came from, just send me or Mr. Hawke an email and we can help. And then this one I did just do on my graphics calculator. Okay, so I get n is equal to 34.77 or negative 47.935. So we reject, n must be positive. And this one here, if we think about it, at n equals 34, we're not going to have hit 1,000 kilometres. So we need to have n equals 35. So after 35 weeks, he'll have run 1,000 kilometres in total. And you can check that by putting in S of 35, working that through. So what do we get? We get 35 over 2 times 17 plus 34 times 1.2, and I got that gave me 1,011.5 kilometres. So that's good. So you can always check these back when you've done these tricky ones and make sure that you're on the right side of the value you're getting from your formula. Right, the next question I think is one about an eating competition, which is kind of gross. Where are we? Right. Oh yeah, okay. Gabe has been challenged to an eating competition. He's getting ready for it. On the first day he ate 2 pork buns, and each day he eats 3 more pork buns than the day before. Gross. Okay, so when will he have eaten a total of more than 100 pork buns? And then, on which day does he eat his 1,000th pork bun? It's very, very similar to the first question. So I'm just going to go through with these and put the quadratic in and then show you what we need to do to check. So for this one with Gabe, we have A equals 2 and D equals 3, and we're trying to solve the sum being greater than 100. Whoops, not 1,000, not yet. So setting that up, we get n over 2 times 2a plus n minus 1d is greater than 100. Notice that I'm always putting that formula in with the substitutions shown really clearly. So we've got this. And we've got a couple of lines of working, or at least one, and then we have 3n squared plus n minus 200 is greater than 0. So solving that with the quadratic formula, just to make sure we're practicing that, gives me this. Two values of n is equal to 8 or negative 50 over 6. So it's not realistic for that negative one. So it's not realistic in context. So in 8 weeks, he will have eaten 100. So is that enough? No, not enough. When will he have eaten more than 100? In 9 weeks. Actually, maybe it's days. Let me just check if I've got that right. I think it's days. Yep, it's days. It's not weeks. Okay, forget about it being weeks. He's really cranking up the pork bun eating. In 9 days, he'll have had 100. More than 100. Right, what's next? The next one we're going to do is when has he eaten more than 1,000? Honestly, guys, this is getting kind of repetitive. So for that one, for 2b, going back over, I'm just going to go to the answer, okay? Because this is, yeah. Right, when will he have eaten his 1,000th pork bun? Same kind of reasoning. We get 25.66 or negative 25.98. And we're going to reject this one because it's negative, so not realistic. So on day 25, he hasn't eaten his 1,000th bun. So you want to be a bit careful here. It's pretty easy to say that it's going to be 25. So it's worth checking what's the sum of 25 and then what's the sum of 26. So I'm going to do that now rather than doing all the repetitive stuff. So S of 25 will give me 25 over 2 times 4 plus 3 times n minus 1 is 24. That works out to be 950. And then S of 26 works out to be 1027. So on day 25, he hasn't eaten it. He needs 26 days. Next up, we've got Kaya and the sausage sizzle. Again, we can see that it's an arithmetic progression because it's got a gap of 10 each day. And then he stopped when the sales got to a certain level and he'd sold this many sausages. So this one's slightly more interesting. I'm going to set the quadratic up and then show you what we get. So 5940 is equal to 510n minus 10n squared. So when we go through and we solve that, we get n is equal to 33 or 18. So this is the first time that we've got two positive solutions. And you might want to think about why that's happening. If you think about your parabola, that is telling you that we've got a root at 18 and a root at 33. And that means that in between those values, we're assuming that he's selling a negative number of barbecue sausages. So it doesn't make sense. So in context, the one we're looking for has to be the first one, right? So we want to explain that a bit. It makes no sense to sell negative sausages, negative numbers of sausages. If I were a proper YouTuber, I would be typing that nicely, but never mind. It makes no sense to sell that, and I would draw a graph like that, right? So just a really quick sketch. So we're going to assume that n is equal to 18. And then the last question is asking us how many sausages did he sell on his last day. So finally we get to use that other formula, which is the term number, and that's a plus n minus 1d. So on that last day, he sold 250 minus 17 times 10, which meant he sold 80 sausages. Right, question 4, which was pretty funny. It's about Mr. Hurring and his origami, so clearly real life inspiration here. On the first day, Mr. Hurring folded 40 pieces of origami. Right now, I've seen him, and that's quite realistic, I think. Each day he makes 3 more than the day before, and he needs to make up to 1,280 bits of stuff. So when you run that through, I'm just going to give you the answer, guys, because I reckon no one out there is watching anymore. We get n is equal to 19.07 or negative 44. And again, I'm using the formula for the sum and I'm solving for n. So he will have made enough here after 20 days, right? After 19 days, he is going to be just short and the sculpture is going to fall apart. So we have to have 20 days, not 19 days, and you can check that. And then the way I interpreted the next question was that he makes each student who doesn't study enough fold a piece of paper before they leave. Then he will increase his daily total by 15. So my interpretation here was D is going to go up to 18 and A was going to stay at 40. So running that through, we get the sum. How many days will it take us? We end up with n is equal to 10.33. So that's not going to be enough. On the 10th day, he will be short. So we need to have 11 days. Right, 11 days once that's happened. Okay, if you are out there and you have watched right to the end, even if you're in 12 MCA, come and see me and I will shout you chips from the canteen just for persevering with what is possibly the most boring video I've made this year. Okay, have a good weekend, guys, and I will do the geometric distribution ones later on today or tomorrow.